So for this lesson, we are going to be talking about hyperbolas. So hyperbolas are the conic section that is created by the locus of points such that the difference of the distances from any point on the hyperbola to two fixed points remains constant. And those fixed points, again, just like in ellipses, are called the foci. So in an ellipse, you could add together d1 and d2 from the foci, but on a hyperbola, you are going to subtract d1 minus d2. And so those are the distances that remain constant for all points on the hyperbola. So your hyperbolas, you do have like ellipses, a horizontal version and a vertical version. So that horizontal version opens left and right, and you will have two curves that will be a mirror image of each other. And then the vertical opens up and down. So just like the ellipse, you do have a center, and then that center is in between the two curves. And you have two vertexes. And so these will be kind of the like the lowest and highest point of each curve is kind of what everything will come out from. And so just like the ellipse, that center is the midpoint of the foci. It's also the midpoint of the vertexes. And those vertices are going to be plus or minus a units away from the center. Now, in this case, your vertices are going to be in between the foci and the center, because the foci are actually inside of your curves. And actually, I should be writing this as focus, because when it is by itself, then it is a focus. It's only foci when it is plural. Okay, so those co-vertices then are plus or minus b units away from each other. And they are going to be, again, like the ellipse, perpendicular to the vertexes in that line. And so then those vertices, they join and become what we call the transverse axis. And the length of that transverse axis is 2a. So that is almost like the major axis, but not quite. And then the distance between those co-vertices, that is what we call the conjugate axis. And so that has a length of 2b. So the asymptotes are diagonal lines that kind of guide your curves. And we will have a formula to find those asymptotes, and we'll actually bring that in here in a second. So then your foci are always plus or minus c units away from each other, just like the ellipse. And your formula to find c is your Pythagorean theorem, pretty much. So c squared equals a squared plus b squared. And so let's look at our standard form for hyperbolas. So we do have different standard forms if you are horizontal or if you are vertical. So for your horizontal, you have x minus h squared over a squared minus y minus k squared over b squared. And then if you're vertical, you are going to have y minus k squared over a squared minus x minus h squared over b squared, and that equals 1. So your transverse axis can have an equation that is y equals k, or if it is vertical, it is x equals h. And then your conjugate axis on the horizontal has an equation of x equals h, or for the vertical, it's y equals k. Now your asymptotes, those are going to have the equation of y equals plus or minus b over a x minus h plus k. And then on the vertical, it's going to switch. And you're going to have plus or minus a over b times x minus h plus k. So to graph your hyperbolas, you want to write your equation in standard form. For these graphs, most of them are there already, if not all. You're going to graph your center, graph your vertices. You'll use your denominator of a to graph those vertices. And then your co-vertices, you'll use that second denominator of b, and you'll get those plotted. Then we will use c squared equals a squared plus b squared to find and graph our foci. And then we'll write the equations of our asymptotes and graph them. We do actually have a shortcut for getting those graphed that I will show you that uses the center. So let's go ahead and look at our first hyperbola. So we have x squared over 4 minus y squared over 25 equals 1. So our center is going to be 0, 0. And then we have led with x. So this is a horizontal hyperbola. So we are going to look at our first denominator, which is 4. The square root of that is 2. So from 0, 0, those vertices, we are going to go left and right 2 for both of these. And so that gives us vertices at negative 2, 0 and 2, 0. Now our co-vertices, we are going to look at that 25 that's under our y's. Square root of that is 5, so we are going to add and subtract 5 from the y. So we have 0, 5 and 0, negative 5. And so what we're going to do is we're going to go ahead and draw our two axes. Oops. So here's our transverse axis, and then our conjugate axis is going to be vertical. And sometimes it helps actually to kind of just draw in this little box that's created by those two lines, because it's going to be as wide as your conjugate axis and as long as your transverse axis. So now for foci, we're going to do c squared equals a squared plus b squared. So we'll have c squared equals c4 plus 25. And so that is 29. So c is the square root of 29, which is approximately 5.4. So the coordinates of our foci are negative 5.40 and positive 5.40. So it's going to be 1, 2, 3, 4, 5.4. 1, 2, 3, 4, 5.4. So about halfway. So then for those asymptotes. So remember, your formula for this is y equals plus or minus, and that is going to be b over a. So our b is 5. Our a is 2x. Let's see, minus 0 for h. And then plus k, so that's 0. So those are going to be your centers. And so that's going to give us y equals plus or minus 5 over 2. Well, so that is our slope. So y equals plus or minus 5 over 2x. So we're going to go up 5 over 2. And notice the first time we do that from our center, since that is actually our intercept as well, then we hit the corner of that box. And that's actually always going to happen whenever you see, whenever you draw these asymptotes. And then we're going to have to drop 5 and run 2. So depending on what your center is, it won't always be your y-intercept, but it will always do this to your box. So it gives you a little bit more of a guide. So now we're going to draw in our hyperbolas. And so we're going to go from our vertices, and we will just curve out towards those asymptotes and use them as a guide. And there we go. All right, so for number 2, we have our center at 3, -1. So we're going to go ahead and graph that. So there we go. And then our vertices, well, our A term, because this looks to be, actually, I think this is going to be horizontal because X is in front. And so our A term is 4, so it's plus and minus 4. So we are going to go 4 on each side. So 1, 2, 3, 4. 1, 2, 3, 4. That gives us vertices at -1, -1, and 7, -1. Now our covertices, we actually have a 1 technically as that denominator since we don't have anything, and the square root of 1 is 1. So we are going to go up 1 and down 1 from that center. And then we've got, let's see, 3, -2. So we have 3, 0, and 3, negative 2. And then again, we might want to just go ahead and kind of sketch ourselves in that little box. This one's going to be really little, but it does help us with those asymptotes. So our foci, that is going to be c squared equals a squared plus b squared. So we are going to have c squared equals 16 plus 1, which is 17. So c is the square root of 17, and that is approximately 4.1. So that puts our foci plus or minus 4 away, or 4.1 away. So just barely outside of our vertices. So we are going to have vertices at negative 1.1, negative 1, and 7.1, negative 1. So then our asymptotes, we are going to have y equals, and it's plus or minus b over a. So that is going to be 1 over 4 x minus h, which is minus 3, plus c, and that is going to be negative 1 for the k. So then we are going to distribute. So y equals plus or minus, actually it's probably going to be best to just split this up. So y equals 1/4, x minus 3 minus 1, y equals a negative 1/4, x minus 3 minus 1. So we have y equals 1/4 x minus 3 over 4, and then minus 1. Y equals negative 1 over 4x plus 3 over 4 minus 1. And so that minus 1 is going to be 4 over 4. So y equals 1/4 x minus 7 over 4. Y equals negative 1/4 x. And then 3/4 minus 1/4 is a negative 1/4. And so this is one of the reasons why I use that box quite often too, is because those y-intercepts are just about impossible. So what we can do is we can actually use our center, and once we have our slope, go up 1 over 4, and then up 1 over 4, down 1, back 4, down 1, back 4, down 1, back 4. Or to me, it is actually easier to just draw a smooth line for those. And then we will draw in our curves. So we will have a little curve right here. And then over here. Okay, so let's go ahead and look at number 3. So we have a, looks like we have a vertical hyperbola this time. So we have a center at 4, -2. So 1, 2, 3, 4, down 2. And then our vertices, we are looking at our first denominator of 2, so that's plus or minus 2. So that puts our vertices at -2, 6. And actually, I have these switched. That should be -2, 4. So -2, 6 and -2, -2. So we actually should be -2, 1, 2, 3, 4. And then -2, 6 and -2, 2. I'm sorry. There we go. All right, so then our co-vertices, those are going to go side to side. And so our b should be 3 since it's the square root of 9. So that gives us co-vertices at 0, 3 and 0, -9. So we have oh, I just totally looked at the wrong ones. We should have -5, 4 and 1, 4. So we have 1 and then 1, 2, 3. So there we go. So then we have our little box that we can draw. So we get, see, our foci, and that is c squared equals 4 plus 9. So c squared equals 13. C equals the square root of 13. And that is approximately 3.6. So that gives us foci at -2, 7.6 and -2, 0.4. So about here and then here. So then our asymptotes, we are vertical. So that is going to be y equals plus or minus a over b. So that's going to be 2/3 and then x plus 2 plus 4. So we will have y equals 2/3 x plus 2 plus 4. So we have 2/3 x plus 4 over 3 plus 4. And that is going to be 2/3 x, and then that's going to be a 12 over 3. So plus 16 over 3. And then for our y minus, so y equals -2/3 x plus 2 plus 4. And then that is also plus 12 over 3, so that is plus 8 over 3. So y equals -2/3 x plus 8 over 3. So again, we have y-intercepts that are just ugly, but you can use that slope and go up 2 over 3, up 2 over 3, up 2 over 3 from your center. And we have our line, and then we go down to over 3. And then we can go ahead and draw in our curves from the vertice, head towards our asymptote. And there we go. All right, so the number 4. Let's see if we can get through this one a little faster. So we have a center of 0, -3. Knock down that size. And so we're going to be right here. And then this is a horizontal hyperbola. So we are going to go side to side for our vertices. So we're going to go plus or minus 5. So that puts our vertices at -5, -3, and 5, -3. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then our co-vertices, we're going to be at 0, 3, and 0, -9, because we need to be plus or minus 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And of course we can add in our box. And there we go. So then our foci, that is c squared equals 25 plus 36. So c squared equals 61. C is the square root of 61, which is about 7.8. So that puts our foci at -7.8, -3, and 7.8, -3. So we will be, let's see, about here and here for those foci. So then our asymptotes, we are at y equals plus or minus, we have b over a, so 6 over 5 times x minus 0 minus 3. So that is going to be y equals plus or minus 6 over 5x minus 3. So we're going from that center this time. So we're going to go down 6 over 5, up 6 over 5. Oops. And get those drawn in. And then we will draw in our hyperbola. So from the vertex towards the asymptote, and then from the vertex towards the asymptote. And there we go. All right, so let's look at some rewriting equations. So we want to try to get to our standard form, and there will always be one of our squared terms that is negative that we will have to deal with. So you will either have to factor out a negative to make it happen when you complete the square. So do watch out for that, because the one that is negative needs to be behind the first term. So it kind of needs to be the second term. So in this case, we've got a negative on that y squared. So I'm going to put my x's in front. So 9x squared plus 90x minus 16y squared equals 351. I'm going to have to complete the square with the x's. So I'm going to go ahead and factor out that 9. So I have 9 and then x squared plus 10x plus something minus 16y squared equals 351. And then I'm going to have to, of course, add 9 times a value. So we have half of 10 is 5. 5 squared is 25. And so that gives us 9 times x plus 5 squared minus 16y, and that equals 351 plus 9 times 25. 9 times 25 is 225. And that is 576. So we are going to have to divide everything by 576. And so 9 divided by 576 is 1 over 64. So we have x plus 5 squared over 64 minus y squared over 36, because 16 divided by 576 is 1 over 36, and then that equals 1. So there we have our standard form, and this one is horizontal since x is in front. Now for our next equation, we're going to have to add y squared to each side, and that does tell us that we are going to have a vertical equation this time because that y squared is positive. So we're going to put all of our y's in front. And so that's y squared minus 6y. Those are actually ready to complete the square. And then we have minus 4x squared minus 56x equals 287. So that gives us y squared minus 6y plus something. And then we are going to subtract 4 and have x squared plus, and then 56 divided by 4 is 14. So that's 14x plus something. And that's going to equal 287 plus our first blank, and then plus 4 times our other blank. And actually, since that is a negative 4 on there, we're going to have to subtract this. So we will have half of 6 is 3, and 3 squared is 9. And then half of 14 is 7, and then 7 squared is 49. So we will have a negative 4 times 49. And so when we factor, we have y minus 3 squared minus 4 times x plus 7 squared, and that equals that equals just 100. So we have 100 that we need to divide by. So we will have y minus 3 squared over 100. And then 4 over 100 reduces to 1 over 25. So we'll have minus x plus 7 squared over 25, and that equals 1. So then we will, on 7, go ahead and add that 4y squared. And since it's going to be positive and our x is negative, we are going to put the y's in front. So we'll have 4y squared plus 64y minus 9x squared plus 36x equals 104. Then we will go ahead and factor. So we'll have 4 times y squared plus 16y plus something, and then minus 9x squared plus 4x plus something equals 104 plus 4 times whatever that something is minus 9 times that something. So we have half of 16 is 8, and then 8 squared is 64. And then half of 4 is 2, and 2 squared is 4. So we will go ahead and factor. So we have y plus 8 squared minus 9, and then x plus 2 squared. And then our 104 plus 4 times 64 minus 9 times 4. That is going to give us 324. And then we're going to divide by 324. So 4 over 324 reduces to y plus 8 squared over 81 minus, and then the 9 over 324 reduces to 1 over 36. And so that gives us, let's see, x, actually that should have been a minus 2 because we didn't ever flip the sign on the 4 when we factored. And so that will be x minus 2 over 36 equals 1. Okay, so for number 8, we're getting close to done. We have, let's see, we need to subtract the x squared and add the 24y. And so it looks like we need to have our y's in front again. So we'll have 4y squared plus 24y minus x squared plus 12x equals 196. And so then we will go ahead and factor out the 4. That leaves us with y squared plus 6y plus something. And then we will need to go ahead and factor out the negative for the x's to have the minus. So that'll give us x squared minus 12x plus something. And so we'll have the 196 plus 4 times something, and then minus the something that comes from the x's, since we had to factor out that negative. So then we have half of 6 is 3, and then 3 squared is 9. So we'll have 4 times 9. And then half of 12 is 6, and 6 squared is 36. So we'll have a minus 36. So actually, 4 times 9 is 36, so we actually will cancel out our values in that case. So we will have 4 times y plus 3 squared over, actually we don't need to do that yet, minus x minus 6 squared equals 196. And we'll divide by the 196. So we will have y plus 3 squared over 49 minus x minus 6 squared over 196 equals 1. Okay, so let's talk about eccentricity. So our formula for eccentricity is the same as it is for ellipses. That is E equals C over A. So it's always the same for every conic for eccentricity. And the eccentricity for an ellipse always has to be between 0 and 1. But for a hyperbola, that value always has to be greater than 1. So one thing you can do to find out if you have an ellipse or a hyperbola when you're just looking at the equation is find your C and then calculate your eccentricity, because it will actually tell you. So for these two equations, we are going to look and see what the eccentricity is. So for number 9, we have 9 and 81 as our denominators. So c squared is going to equal 9 plus 81, which is going to be 90. So c is the square root of 90. And so I'm actually going to simplify that one. So we've got 3 square roots of 10. And then we know that our a is 3 because that's going to be our first denominator. So our eccentricity is 3 square roots of 10 over 3, which that is the square root of 10, which is approximately 3.16. And then on number 10, we have c squared equals 225 plus 64. So that leaves us with c squared as 289. So c is 17. So our eccentricity is 17 over 15, which is approximately 1.13.